task actually for the day is going to be kind of an icebreaker to let everybody get to know each other, because we're going to be working together. So wherever you are, just leave your stuff and stand up. By order of birthdays, only month and day. Month and day. So a circle-like shape somewhere up here.
Big, massive.
Yes. Are we allowed to talk? Yes.
Close the one of the other.
Where's January?
Do you even have time to do this stuff anymore?
Where's January?
Where's January first? April.
July.
April. Birthday is my birthday.
Come join us. We're arranging ourselves by month and day of birth.
Who's last? We haven't finished yet. Who's last? We have to close the circle.
I mean, I'm the only change. That's right. My fault.
Put your right foot.
Okay, so where's the beginning of our calendar year? Okay, so let's just give off our birthdays, month and day.
January 15th.
February 22nd, March 26th,
April 5th.
April 22nd.
27th.
May 24th, May 29th, June 1st,
June 1st.
June 19th, June 23rd,
July 2nd.
July 3rd, July 8th,
July 28th.
July 31st, August 3rd,
September 9th.
October 18th, October 16th. That's all right, come and join us.
In the middle.
December 27th.
Very nice. A Christmas birthday. Okay. And I heard you have some birthday twins. Where are you? Yes. Okay, so you guys were both born on June 1st. Okay. So I'd like you to contemplate this as you return to find a group of 3 or 4 people at one of the first 4 rows. So in one of the first 4 rows, you're going to find 3 or 4 people who you sit with. Okay. So you may have to collect your belongings and then relocate. And the thing that you're going to consider is what is the probability that in a group of our size, at least 2 people are going to share a birthday? So what's our total group members? Oh, I don't know. We were 24 when we first started, and we've added 4 or 6 or 7 people. So, all right, go find your table and contemplate. What is the probability that you'll have at least 2 people to share a birthday?
Everybody shares it.
They are at one of the first 4 tables at every seat. Here you go. If you are at a table at a handout, you want to these people to work. Amber close, I guess, close.
Are you too? Is it there? I'm just recording. You're recording. All right. Where can I go? There's no. Here we go.
This is Can someone read out? How many of us are we? There's 29 of us now. Okay, there's 30 of us. So do you think the odds were pretty good that this would happen, or it just kind of was luck that it happened? I think it's slim. You think there was slim chances it was just like a crazy, crazy thing that happened? Yeah. Okay. Anyone else feel that way? That it was just a crazy coincidence that we had two people to share a birthday? I see some shaking heads. It seemed like, no, I feel like this was more than just chance. Fate. It was fate. Planned. No, it wasn't planned. So I'm not going to give up one, but I will give just a bit of closure. When there were only 24 of us, I said there is a better than 50% chance we are going to have two people who share a birthday. And as more people started coming in, I was like, oh, we're definitely going to have two people who share a birthday in this room. And now that there's 30 of us, I know that it has happened. I would bet again, if I saw a room with 30 people in it, I would say, there is, more likely than not, almost certain you're going to have two people who share a birthday. If you're interested in finding more about this problem, Wikipedia has a really good database, actually. So they explain a lot about why this is so certain and how you can find out exactly how certain it is. Okay. So some information for you. All of our slides for the presentation are going to be available online, so you don't feel like you need to copy everything from the slides, but take notes on whatever things kind of stand out to you. Additionally, the handout that you have in front of you will also be made available digitally. If you want a clean copy that you can print off, that's fine too. So feel free to mark up the handout that you have. And then if you haven't already, make sure that you know the people's names who are sitting next to you, because you're going to be working with them. And then there are some information cards. There are information cards at your kind of place for you to write your name and all of that stuff. There's two ways that you can get information to me so that I can send you the presentation and the handout. You can either fill out the card or you can use that awesome QR code, go online and fill it out yourself. Just fill in your information and I will automatically send it to you. Okay? Okay, so who are we? This is Zach Hagman. If you haven't guessed from our last name, we really are related by marriage. So this is my husband, and I am Jenny Hagman. I work with the Center for Math Teaching. It's a nonprofit that alum for 6 we have a full year curriculum. If you want more information about us, we've got a booth. You can come and see us. Okay. I'm also a lesson study facilitator for a grant out of Ontario, Montclair. If any of you are not familiar with lesson study and you'd like to know more, please feel free to talk to me about that. I really, really love math. I am a typical math nerd. I do math for fun. I really do. I'm also of RSBCMTA. That's the Riverside San Bernardino County Math Teachers Association, which is a affiliate. So if you are in Riverside or San Bernardino counties, we are your local affiliate. So if you'd like to join us or if you want more information about us, please come talk to me about it. Okay? So today, what we're going to focus on are two kind of branches. So we're going to do a name scores activity, and then we're going to do fish and lake activity. How many of you are familiar with the cognitive demand spectrum? Yeah, so some of us have some familiarity with it. So we go from the lower end of cognitive demand to the higher end of cognitive demand on the right. Things like memorization or and then we're going to try to be a procedurally math that really want to strive to make connections so that the math that we're doing has a lot of meaning to it. So here we go. So for your name scores, what I'd like you to do is you have your handout, and this chart is on your handout, and I want you to use your first name or nickname that you like to use. I'd like you to write that down and find out what your name score is. And then you have index cards at your table. And what you're going to do is you're going to write your name score nice and big on the card, and you're going to write your name small underneath it. Okay? So you're going to use your handout to find out what your name score is, and then find an index card, and then you're going to write your name score. More index cards?
Just start first.
First name.
They are all helpless.
Jenny, focus on the index card. You're going to have your name score, which is the number, and then whatever name you calculated the name score for. So after you're done, I have a question up here for you to ponder and a task for you to complete. They are all out here, so do you need another one?
Yes.
There you go. Yes. Whichever version you want to use. Oh, that's okay. So I will give you a card to put your here.
Oh, I see.
So do you think it's possible to know whose name has a score of 50? Too many variations? Okay. So there's a lot of ways to make a score of 15. Yep. So then would that mean that in this room there are probably some people who have the same number but not the same name?
Yes.
Yeah. Has everyone taken red beads? Yes. For those of us who have taken red beads, if you have extras, look around for the hands of people who still need red beads. Yeah, so there's folks in the back who still need access to red beads. They're empty little cups.
You need more beads?
So after you have your red beads, I'm going to ask you to get up and we're going to have some more movement. So it's going to be really helpful if you have your red beads in a cup rather than in your hand, or on a plate rather than in your hand. But you want something to have your beads on. Okay. So you're going to share first with people at your table, and then tables are going to branch out to other tables. And then you're going to branch to other tables. And what you're going to do is you're going to share your beads as equitably as you can between other people that you meet. If I have 12 beads and I meet someone new who has 20, I need some more of their beads because they have more than me. If I have more beads than someone else, I want to give them some of my beads until we have as close to the same number of beads as possible. Does anyone have any questions about what we're going to do? By the time we are done, everyone in the room will have as close to the same number of beads as they can. Okay, so start locally with your own table group and then branch out. I have 12.
So we just went up.
Are you doing this?
Okay.
And you're just using the cards who have no beads.
12. No, they all have 12.
We have
All of us have 12. So you're supposed to do what do you have?
Like if you want, I have
12. How many do you have now? Yeah. 11. Wait, what do you have?
Did someone say 10?
Oh, yes, I have 12.
My daughter goes to UCLA. She's going to graduate this year. Yeah. Yeah. Her first year, you know how they like to drop 30%. Yeah. So her first year gym class, she just like, oh my gosh, I'm not going to be a doctor anymore. So, no. Human biology and society.
Yeah. That was fine. I could just see that. I could see kids doing stuff.
So what did you find as you were circulating? Yes.
At first, was saying the number. I don't think people wanted to give up their bead. And then it was like, well, it's mine. Okay, I don't, you know. And then as we started walking around, it was a minute. That person has 10. You need to give them one, so we'll all have 11. It started to be a real collaborative kind of thing, and we started looking for people to help. Okay, so.
Anything else that you found as you were doing this?
Like, I have a short name and 7. I think with short name, it's got a higher than 7. So we add probably around 9. And then there are too many people that are 12. It's got to be higher than 9. So we get sort of started.
Okay, so you were testing how many people we're going to have.
Based on one of my name.
Okay. Did anyone else do that kind of estimate? Thinking about, I wonder if I'm going to have to give beads or if I'm going to receive them. How many beads did you end up with?
11.
I heard some 10s and I heard some 11s. Was there anything other than 10 or 11? We hope not. Why do we hope not?
Did what we're supposed to do.
That's really good. Not want someone to have something different from 10 or 11 beats. That means we didn't completely share. Yeah. Right. If they had a higher number than 11, then they should have given up some of their beats, and if they had lower, then someone else should have given them more beats. Right? Okay. So what does that mean? The fact that it's 10 or 11, that we're split between 10 and 11. What were we just doing by doing this?
We're averaging according to a letter scale.
We were averaging, trying to find the median. We were finding the median. Were we finding the mean? Or were we finding the median? Or were we finding the average? Any of those things like that. Okay, so we're going to clarify that as we go on. Go ahead. Okay, so we are going to create a human number. So you're going to get to move again. So this time we're going to go back to your number card that has your name, and we are going to create not quite a number line, but almost like a dot plot, but a human dot plot. So there are several of us who have the same number. We're going to stand in front of one another so that we can clearly see that there are a lot of us. Okay? All right, so over here against this wall again, we're going to line it numerically. Left will be the least numbers, and on the right will be the greater numbers.
Watch your step. Watch your step.
Chad has 19 is joking. You just have like
Yeah, a bit more.
a little bit more. That's your generation. What about you? What's your name? Suzanne. Has a Z in there. Okay. J's and Z's. Okay. So I have, what do you notice just from doing this? Outliers? What do you mean outliers?
Don't fit in.
You have some extremes?
My parents were creative with my name, so I don't know. You can see this.
So what is your name? Tara. Okay, and so you have a score of 4. Okay, 1 for each letter. What else do you notice as you kind of look and see how people are arranged? You might be able to see mode. How would you be able to do that?
Well, not necessarily with the layers, but maybe if we were in boxes, like clearly staying like.
So everybody was regularly forward. Yes. How would you know this? Well, so I have some cards, you know what? You see those from there? Yeah. So who gets this card?
Yeah.
Does it go to one person or do 2 people share it?
2 people share it.
You guys?
We share. Stop, then if we share with the co-hosts.
Oh, okay. From here, it's hard to tell what you're doing. Because you think I can see it better from here.
And we're not easily spaced down.
We're not able to space apart. How good do you do to find the meaning? We have enough time. So someone just had an idea about raising hands. We're going to raise hands from the ends. And one person from either end is going to raise their hand. Okay, what is that going to tell us? We're taking from the end what? It's telling you to somewhere in the middle, right? Okay, so let's actually do that. Please so down. You will be able to see each Okay. Okay. So we're gonna not go too fast with this because I want us to make sure that we don't get off on here. So one person from the ends, a second person from the ends, a third person from the ends, a fourth person, a fifth person, a sixth person, a seventh person, an eighth person, a ninth person, a 10th person, 11th person, a 12th person, 13th person, 14th person, 15th person, 16th person, 17th person. Oh, is there an 18th person? Oh, you guys are now bloods. What does that mean about the median? It's actually between the two of them, right? It's not either one of them. You must have an even number of people who participated, right? So well, you guys will want that for the end. Is there a person who represents the mean? No. No?
It's based on. No, it's not a person. 11.
There's not one.
That's what I was thinking this minute. But what I want to do is I want to call off our numbers in order so that Zach can write them down. Because we're going to use that information to help us with something else. Okay? So in order, here we go. 4, 5,
7.
7.
7.
7. Pause.
I have 4 sevens.
6 of them.
Okay. 8, 8, 8, 8, 8. So there were 5 8s. Okay.
9.
3 9s. 1 10. 11, 4 11s. 2 12s.
13.
13 13s.
14.
1 14. 15. 3 15s. 1 16.
19.
And 2 19s. All right, thank you guys so much. You guys can return to where you were sitting. You can just take those cards with you, that's okay. And I want you to think about, is there a particular person who actually represents the me?
Are you still at UCLA? My daughter is.
No, someone else will be saying.
All right, so we have our data for us as a group. I'd like you to go ahead and report it on your handout. Four,
6 7.
5, 6 7s. 5 8s. 3 of the number 9. 1 of the number 10. 4 of the number 11. 2 of the number 12. 4 of the number 13. 1 of the number 14. 3 of the number 15. 1 of the number 16. And 2 of the number 19. So what do we mean when we ask about the number of observations?
How many of us? Number of scores.
How many of us participated in this? How many name scores we actually got? How many name scores were there? 34?
Yes.
So take a couple of minutes to look at the measures of center and actually record them.
Bless you.
What math practice was that? So what were you doing is you were calculating the median based on the data that you have in the table. So you went to where the middle of the data set was, and then the filter numbers, because there was an even number of data points. So what was our median again? 10.5. How does that relate back to what we were doing when we had our human dot plot? It was between two people, which told us that we had to find out what number would be between them. So what are you doing when you calculate the mean?
You're finding that average square.
So is finding the mean the same thing as finding the average?
It's one way.
Do mean and average mean the same thing?
Yes.
Yeah, that was a good point. The arithmetic mean is the same thing as the average that we think about. There's also a geometric mean, but that's not what we're talking about. Okay. So what actual calculations are you doing to find the mean? Okay. You're adding up all the numbers.
Yes, and dividing by the number of
Dividing by the number of
observations.
observations, which in this case was the number of people in the room. How does that relate to what we were doing with the red beads?
We were averaging.
Red beads.
We were sharing equally.
We were sharing equally. Is sharing equally another way to think about division?
Yes, we're dividing everything.
One way of thinking.
That is one of the ways to think about division, right? When I think about fair share partitive division, that is making sure everyone has their fair share. So when we were going between two people and sharing beads, it would have been the same as if all of us had collected our beads together as one giant group and then doled out some beads for each person. So you're doing averages of a bunch of people. You're going to this entire group. Did you know you could do this? Did you know that that's what the average actually represents? A sharing, an equalizing of all of the numbers in a set. If I think about the numbers like 13, 14, and 15, I take one from 15 and I give it to 13 and everybody has 14. That's what's happening with an average. Okay. Let's go back to the PowerPoint. And what's more? And what's more? Oh, sorry, thank you. Right there. Okay. So what do you think best represents the middle of the data, the center of the data? Measure of center. That represents the middle of the data. The center of the data. The median?
Well, the middle. In this case, they're both the same.
Yeah, so you are looking at an overall picture of the data. What is a better representative of the data? Is the mean a better representative, or is the median a better representative?
Depends on what your outliers are.
They really look in this case. What would you wonder?
Well, I was thinking from the student's perspective, but maybe some teachers too, but nobody asked him. Nobody asked him. How can that be the representation? Nobody asked him.
So you're wondering what kind of meaning those numbers have. Okay. So it's hard to tell in this case what might be a better representative. I think you might have a case for either one. in data sets where things are much more spread out. You have more of those outliers on either end.
You mean like when you have a $100,000 house and your whole neighborhood has $100,000 houses, that's a $1 million house, you're going to be half of the average of the people that are in the neighborhood. I'm not changed here.
Yes, that's good or bad?
Yes, you are.
So things can happen when you introduce outliers, right? Which didn't really happen out of 4 and a couple of 19s. That wasn't really outliers. They were just the minimum maximum values. They weren't really, really far away from the rest of the data. There wasn't someone who had a name score of like 70. Definitely an outlier. Way beyond their classes. Variability was very
I think what your range would be more like the numbers that,
So you think the variability is like the spread of the data? Okay, you think the range would be a good representative?
Yeah.
How do we find what the range is?
take the top and the bottom number and subtract them.
Yeah, find the difference between the maximum and minimum values. So in this case, what was our range?
19 and
19,
Our range was 15, okay? What other measures of variability are there that students are going to come across in 6th or 7th grade? Say that again? Oh, what?
quartile.
Quartiles? Okay. What are quartiles? Yeah, so we have a median in the secondary data. First quartile or the third quartile would be a median of the lower half of the higher half of the data. And a measure of variability. The IQR, what is the IQR? Very nice. The interquartile range, which is related to that, right? The difference between those values, that's a measure of variability. So in this case, was our data really spread out, or was it kind of nicely clumped together? They were kind of nicely clumped together. Okay. All right, let's go ahead. So there are some graphical displays on page 5. I'd like you to choose your favorite one. Okay, using our entire Bloom's data.
I teach SCCSB, and I work with all students.
I think I probably I need to brush up on this a little bit. Okay, so this is correct. Okay. I'll take these. Oh, okay. Started with an even number, and you have a odd number. Just so like 1, 2, 3, 4, 5, 6, 7, 8. So 25% of the data falls here, 25%. So percent between 2 and 3. Okay. How much do you want students to stress? How much do you want them to use visually or like having and I'm looking for 5th or 6th graders. I mean, I'm probably going to have to do a lot of stuff.
So I'd like to bring us back together. For those of us who created a dot plot, did yours look similar to this?
Yeah.
Does this remind you of something else?
Over there.
When we lined up over there?
Yeah.
What about this? For those of you who drew histograms,
I didn't keep it.
did yours look similar to this?
Yeah.
How many of us, by show of hands, chose to do histograms? It's about a third of the room. Did anyone relabel? Did anyone relabel the vertical axes? You did? What did you relabel? Higher. Yeah. On the higher side, just relabeled the y-axis higher. Oh, so you extended this up? Okay. Did anyone choose to scale this differently from how it was given as a scale? Did anyone by 4, by 3? How many of your students will do that if the scale is already on the page? What does that tell us about our students?
Follow.
They're rule followers?
Follow.
To some degree, that would be a good thing, right? Okay. What do we want them to have the freedom to do?
Be independent thinkers.
Yeah.
Do what needs to be done. Make it work for them.
So I want you to challenge you to do this yourself also, right? be okay with changing things so that things fit how you are looking at it. If an established scale doesn't work for you, establish a new scale that'll work even better for you.
Or give them no scale and let them create their own.
Yeah, well, think about how should I scale this so that I can fit all of my data on here appropriately. Is there a difference between the histogram we did on what's the difference between them?
There's a range on the histogram.
What do you mean there's a range on the histogram?
Between 1 and 5, 6 and 10. On the dot plot, it's just one single number.
So which one is more powerful?
Depends on what you're looking for.
Yeah, it depends on what you're looking for?
Yields more information. Is that what you're asking? Which yields more information?
Yeah, so what is one of the advantages of using a histogram? Easier to see where the center is?
Not necessarily.
Not necessarily?
It's on the range.
Depends on how big those numbers are, maybe?
Yeah.
Yes.
I think the kids, they can do that, but I don't think they really understand
What it means.
the histogram. Yeah, because what are we bumping these people together and, you know, these strange, you know, groupings, and I think they would probably be more confused.
So that's a really good point. Why did we group them?
To help us see that 10, 11 magic number. Or me.
Oh,
It created quartiles.
it created some quartiles? Does it create quartiles?
What does it do for statistics? What does it?
What is the advantage of doing it this way?
I can see a lot more of my information, like between 6 and 15. It's easier to see it this way than the other way.
So it's easier to see that most of my data, most of our name scores were between 6 and 15. Would you agree with that? Are there any kinds of things out in real life that really do categorize things like that by groupings? Sure. What kinds of things?
Surveys where they ask for your age and
SBAC scores? Someone said insurance, or any of the surveys where they ask you for your age. Some ask for your age, but some ask you to identify yourself by an age range. They're asking you to put yourself in one of those categories, right? So getting students used to this, it may be uncomfortable for them now, they may not be used to it, but it'll really help when they get to 8th grade when they start talking about categorical variables, right? When they start thinking about those ways to categorize things.
What would students be able to relate to that comes like that? They don't look at insurance.
They don't look at insurance, at least not yet.
Right. But what's something related to their life? Lumps.
What is something that students have categorical variables of?
maybe any statistics between junior high and high school students, and whether you have 7th and 8th grade range. Testing scores, 9th, 10th grade.
Testing scores may be a way to go. What about something that's even more directly relatable to their life? Their grades might be, right? Their grades would be categorical, different buckets to put themselves in. But something else you might consider is the number of megabytes of data or gigabytes of data on their cell plan. 0 to 2 versus 3 to 4 versus 5 to 6, something like that. Or maybe it's something else. Maybe your school or site does something else that are, instead of being every single number, they group some of the numbers together. What information do we gain from looking at a box and whiskers?
You can see outliers, you can see medians.
Range. We can see the range, we can see the median, we can see outliers. Can we see where the quartiles are? First and third quartile? Can we see the minimum and maximum value? Do we know where most of our data is? Where is most of our data?
50% of our data is
Say that again.
50% of our data is in the box.
50% of our data is in the box. So, and this one is between 8 and 18. Does it also give you some information? The fact that these are approximately the same width, what does that tell you?
Even distribution.
There's a pretty even distribution of numbers. There aren't a whole lot of numbers that are within only a couple of numbers. Because then we would have a very skinny box. Or we'd have a very skinny one of those whiskers, right? So on the back of your handout are standards from 6th and 7th grade, as well as some math practices. I'd like you to take a minute to think about which of these standards have out and what math practices have you personally been working on. And it may not be necessarily the ones listed, so you may have to expand to other math practices.
Yeah, I just yeah, traditional. Almost ready. The next. This is the next. Really challenge. So yeah, all these. Next Monday. Do that.
So what math practices did you feel you worked on?
All of the sixes for sure. Touching on stuff.
The practices, the ones you have listed.
You felt like you worked on all the practices that were listed?
Yeah.
Mm-hmm. Did anyone feel that they worked on ones that weren't listed?
Reason, model, construct.
I had to tend to precision when I calculated that average.
Yeah. You were tending to precision? Okay. Did you feel like you needed to persevere? You needed to...
You were using tools as well, because a lot of us pulled out a calculator.
Yeah, even though I didn't give you an instruction to pull out a calculator, some of you said, I'm going to use a calculator. Okay. Any other practices you felt you worked on? Bless you. So I have a second problem for us to work on. This one is estimating fish populations. Does anyone in the room like to go fishing? All right, we do have some people who like to fish. So if I had a large lake, I didn't already know the population of fish, how might I go about figuring out how many fish are in the lake? What are some possible ways you might do that?
Take a sample.
Take a sample of them,
Tag them, release.
tag them, and release them. Count them one by one, find them all.
Somehow we have to figure out the sound. We have to figure out. We wanted to know realistically how many particular types of fish. We have to have some way of figuring out how many.
Yeah. So we're going to try to do this. So has anyone heard of capture recapture? What is that method? If you were going to explain that to someone, what does that mean? Yeah.
So you would collect your fish and tag them.
Okay.
Go back. Later on.
Did everyone hear what he said? So you would catch some fish, tag them, release those fish, and after some amount of time has gone by, you would go back, you would catch more fish, and you would see how many of the fish that you caught are tagged. How is that going to help us figure out how many total fish we have?
Percentage.
A percentage?
Ratio.
A ratio?
Proportions to the average.
Boy, that math is in 6th and 7th grade. It might be very helpful for us to do that. Okay? So we're going to simulate this. So we're going to capture, and we're going to recapture. What are some things that we might want to have happen in real life, or we might want to assume are going to happen during our experiment? What are some things we want to hold constant? The number of tagged fish. So we don't want, we don't want any of our tagged fish to disappear. However that might happen, being eaten, dying, something, the tag falling off. We're going to assume once a fish is tagged, it will remain tagged. Okay? What else might we want to assume?
The population, the overall population of the fish after a period of time. I think we first tagged it, if there were 100 fish, and there were 100,000, 1 month later, something crazy happened.
Yes. We don't want any kind of event affecting our fish population. So we're going to have a constant fish population, which means when you do this, maintain a fish population of bees. Don't lose your bees because they're your fish. Okay? Anything else you might want to assume?
Are we doing this multiple times?
What do you mean by that?
Meaning, are we going to capture, recapture, capture, recapture? Are we going to like take multiple samples?
We are going to take multiple samples, but we are only going to tag fish once.
Okay, so I'd want the same amount of time to pass between each time I'm taking a measurement.
Yeah, so in real life, right, you would want to make sure that the fish that you've captured, they have time to disperse and get back to life as normal for a fish. You wouldn't want their being caught to affect their behavior. So we ourselves want to assume that. So we are going to help our fish get back to life as normal by mixing them in the lake, okay? So we want to make sure that our tagged fish don't remain on top, but they get thoroughly mixed throughout the lake, okay? Anything else we need to assume about this? there another one? Okay, go there. Okay, so in our particular lake, there are 3 kinds of fish. There are bluefish, green sunfish, and yellow fang. And yes, I did look those up. Those are real fish. Right? They are real fish types. And in your bag, you have blue, green, and yellow beads that represent those different types of fish. Okay? You're going to use a net, a fishing net, aka your little cup. Okay? That's what you're going to go fishing with. And you're going to pull them into your boat. Your boat is that blue plate that you're told. So once you go fishing, you're going to pour out your fish onto your plate so that you can count how many you have. Okay. Your red beads are going to represent what? That's exactly it. They are going to be your tag fish. So you are going to do 1 scoop in your lake to pull fish, count how many you have, and you're going to replace however many of those fish you counted with red beads. And you're only going to put red beads into your bag once. No additional tagging beads. Okay, so all tag fish, we're going to do only 1 time. We're going to make sure that life is usual for a fish. And then we're going to go fishing for a sample. Okay? And then you're going to count number of tagged fish, number of total fish in your sample. There is a place for you in your handout to record this information. And you're going to use that information to help estimate how many fish total do you have in your lake. Okay? But as the bag says, no peeking, I don't want you to actually look and see how many are in here. Okay? So you're only going to use your sampling to help you determine how many fish are in your lake. We have some questions about the process we're going to go through. So we're going to group up so that we can share work a little more equally between ourselves. So we're going to have these 3 tables come together, okay? And then you ladies at those 3 tables are going to come together, and then we're going to have you folks work together, and then you 3 tables, 4 tables, make sides, you can split up. But I want you to come closer together, okay? And you guys can be a group, and you guys can be a group, okay? All right, each of your groups is going to get a lake. As soon as you have your lake, go for it. Lake. Okay. So all of those replace this. That's mine. Go ahead. Plates are there for you to be able to stick it up to you. What's that? Green. Got 36.
I got
39.
39, 36. Did you have how many? Wow, you just did really well.
I don't think we have enough bread.
So we could take 1 handful, put it back in, and put my 40 back in.
Okay.
How's that sound? So that now means we now have 39 and 38, we have 77.
$59.
9.
Yeah, 59.
So then that means able for 18 of the others back then.
I see what it's like.
18. No problem. I'll make sure they get those 18 back in, and then these go in, right?
59.
You know what sucks? I have to leave in 5 minutes because I'm meeting somebody.
We're at 59. What?
Okay, so there's a day in the lake, right? Really shake it out. Day at the lake. And then a scoop.
It's smaller scoop.
So we're counting tagged fish,
Yeah.
counting both.
This is this tag.
Seventy-seven regular fish and 5 tagged fish.
You have to have an S total and an S tag. So now we're supposed to do it again. Back in.
Just see my classroom after this. Bees everywhere. Okay, normal day.
It's 53 total or 53?
56 total, 56 total, 3 tags. I will. Thank you so much. See you guys later.
$61 plus 70. Actually, I have no idea.
sample count.
Just based on the ratio that we keep on.
Find a ratio between the total versus tag and against our initial.
Okay. How about that?
Okay, how many are red? 5 red.
I'm almost down to the bottom. That's
How many red? 1.
Okay. Oh. Interesting. Okay.
so when you go 5 over 82, it's the same thing as 15. How it works. Well, what the line is 5 over 82, 59 over whatever.
Yeah. Or we could also flip it. It's a little easier. Okay.
You can do the math.
Total over tag.
They would divide by 5.
Yeah. We just can write the proportion in.
And confusing now. Part of a whole.
Right. Well, okay,
Right.
so let's see.
They also
Numbers a lot smaller, right?
Yeah.
How much smaller?
Yeah.
Nothing. It's bottom. On the bottom.
A lot of variation.
391. No, it's fun.
Okay.
Now we'll do check that out. You gotta go and think of it. Yeah.
And I don't think that variance, I think I'm gonna do it again. I think that our range is pretty wide, 391 to 1,000.
Yep.
So I don't know if this would be.
That's easy. Always go on. If not, multiply with
Tag fish and sample.
they have to leave the number. So they get the average. 742. Point out the 767.
Take week.
You would still have a hard time.
It could be, it could be. Could be.
Count one.
Yeah, no, they do my cups. Yeah.
Okay. I love this class.
So I want to pull us back together before we end. And I want to find out, how did you estimate how many fish are in your lake? Yes.
We took an average of all of our, as we found out the proportion between the tag, the total that we sampled, and then we took an average of that.
So you said a proportion. So you say the ratio of the number of tag fish to the total population of fish is remains constant. So when you take a sample of them, your sample should have the same ratio, right? So you can look at the ratio in your sample to figure out what your population of fish is. What is the advantage of doing this? Why would we do this? Why would we study this? Yeah, so for some things, like animals, it's not feasible for us to actually go out and count every single fish that's in the lake. And a lot of times it costs quite a bit of money to perform one of these samplings. So the question for us might be, how many samplings do I have to do before I feel pretty confident that I have a good estimate of how many fish are in the lake? Do I have to know just to the nearest 100 fish? Do I have to know to the nearest 1,000 fish? Do I have to know the nearest 10 fish? Is that reasonable for me to be able to find that kind of an estimate? So there are some additional questions that are on the next page. We're not going to get to those, but feel free to take a look at those. This handout came from materials from MathLinks in 7th grade. You can see what that looks like. I'm in booth 427. Again, if you have this information card, if you filled it out by hand, please remember to give it to me before you leave. If you want to go to the website, you get a QR code, you can fill it in online, and then I'll be able to get you a digital copy, a copy of today's handout, as well as the slides for today. And then don't forget to text in your evaluation for the session. Thank you guys so much for coming. Outcome. Okay, so the real outcome of these, they're all different. They really are all different. There were approximately 500 to start, but these have been added and subtracted from them. So they're not all identical. But if I were to do this in a classroom, I would want to maintain somewhere around 500. If you get too small or too large, it's not easy to find out reliable information for sampling. Thank you guys so much for coming. Give me more of the cards. Thanks.
So our bigger